So 5.1, we're going to start working with polynomials. Before that, we're going to introduce monomials. And while a polynomial is many terms, a monomial is just one term. So you guys have done powers before, like exponents, when we did the order of operations. So what we're going to be doing in this lesson is we're going to multiply, divide, and simplify monomials and polynomial expressions. Okay, so this first part is going to be all about monomials. So what we're going to be doing a lot of simplifying. So when we talk about simplifying, what that means in like official math language, to simplify an expression, if there are powers involved, it means to rewrite the expression without parentheses and without negative exponents. All right, so what we're going for here is we want to rewrite the expression without parentheses and without negative exponents. Okay, so that's our end goal. So we've got a bunch of properties. So the properties start off like this. For any real numbers, x and y, and then integers a and b. So in these properties, I'm going to be using x, y, a, and b. So x and y can be absolutely anything. A and b have to be integers, meaning no fractions or decimals, just positive and negative whole numbers. All right, so the product of powers works like this. Say you've got x to the a, and then you're multiplying it by x to the b. So if you've got the same base and then you've got two different powers, this first property tells us that we add those exponents together. Okay, so we're going to apply that property later. Quotient of powers, if we've got x to the a divided by x to the b, this next property tells us that with a quotient like that, we subtract the powers. Okay, and again, these will all make a lot of sense once you see them in action, and I know you've seen them before. Negative exponent, if you've got this, like x to the negative a, remember a negative exponent represents the multiplicative inverse of a number, so we write this as 1 over x to the positive a, or if for some reason you ever see a negative exponent in the denominator, you would flip it up into the numerator as a positive exponent. Okay, so basically anytime you see a negative exponent, you flip it to the other piece of the fraction. Okay, power raised to a power. Let's say you have x to the a in parentheses, and then you raise it to the power of b. In this case, you multiply those together. So this one and this one are most commonly confused. With this one, you would have to have two separate bases. That's when you add them. Here, a power raised to a power is when you multiply them. Power of a product. So let's say you've got a product, x, y, and then you're raising that whole product to a power. If you're multiplying on the inside here, you can distribute that power. Like that. You can't distribute a power over addition, but you can distribute a power over multiplication. And then this is super similar. If we've got a quotient like this, raised to a power, you raise the numerator to the power and raise the denominator to a power. Okay, and then our final property that we're going to be working with is the zero power. If you take anything at all, and raise it to the zero power, you're going to get 1. Doesn't matter what it is that you're raising to the zero power. Okay, so those are your properties. We're going to work with all of those on the next page here. We're going to run through and do some examples here. So I reminded you guys on the previous page, but remember that a monomial, it's either a number, a variable, or an expression. It's just a product of one or more variables with integer exponents. So it's just a product of numbers, variables, with non-negative integer exponents. So the non-negative part we'll get to when we write down our rules right here. All right, so basically a monomial is just one term. The mono part means one, and so there's no addition or subtraction. With polynomials, we'll have addition or subtraction of multiple terms. So when we're simplifying monomials, which is what we're going to be doing for the rest of this video, we've got a list of rules that we need to follow. So we know we're in simplified form when the following things are true. There are no powers of powers. We can't have that. So like what we have in part D down below is a no-go. Can't have powers of powers. Each base appears exactly once. So a bunch of these don't work. See, you've got the A in a couple different spots. Here you've got C and D in a couple different spots. That means you're not simplified yet. All fractions are in simplest form. And finally, this is what I said was coming up, there are no negative exponents. Okay, so let's go through and do some examples. I think you guys have probably seen these before. Assuming that no variable equals 0 just keeps us from ending up with 0 in the denominator, because we know we can't have 0 in the denominator. Okay, so what we're going to do is these all just get multiplied together, because you've just got a term times a term times a term. So no powers of powers, we actually don't have any of those issues here. Each base appears exactly once. Okay, so we've got this A, and this A appears more than one time. So when you have two separate bases with different powers, our first property on the front tells us that we add them. So this, for A, we add these exponents together, and we have -3 plus 2. We'll simplify that in a moment. B to the fourth, so B only appears once, C only appears once. Okay, so we're just kind of going through and checking these items off the list. All fractions are in simplest form. We don't have fractions, so we're not worried about that. No negative exponents. Okay, so let's work on that part next. This simplifies up to a to the negative first. I just combine these up. B to the fourth, C to the first, negative first. So what you do with these is, since they're negative exponents, you flip them down to the denominator. So B to the fourth is positive, so it gets to stay right here. And then A to the first flips down here, and I don't have to write the first power. It's kind of implied. And then C to the first gets flipped down there too. So that would be my final answer. You can kind of run through the checklist and see that all 4 of those are checked off. So that means this is in simplest form. Okay, this one, let's do the same thing. No powers of powers, we don't have that. Each base appears exactly once. That's what we need to take care of here. So first thing is, with these numbers, I can reduce the 15 over -3. So if you divide them both by -3, here you're left with -5, and this cancels. So I have a -5, and then for both of these, I can use my quotient property where I subtract the exponent. So for C, I'm going to subtract 5 minus 2, and that'll be my new exponent. And then for D, I'm going to subtract 3 minus 7, and that'll be my new exponent. So I'm working on step 2 here, but I really kind of just fixed step 3 with that 15 over -3 as well. So this simplifies. I've got -5. C's new power is 3. That's 5 minus 2. D's new power is -4. Okay, last thing is I can't have negative exponents, so I'm going to flip that down to the denominator. Okay, that would be your final answer. All right, let's look at part C. C, I have this quotient property, where if I've got a quotient raised to a negative exponent, not a negative exponent, any exponent, I can distribute that exponent. So I have a to the -3rd over 4 to the -3rd. And then since they're both negative exponents, I'm actually going to swap them both. So I'll have 4 to the positive third in the numerator and a to the positive third in the denominator. And then 4/3, or 4 to the third, 4 times 4 times 4 is 64. Okay, last one in this video. I have this squared power that I can distribute to everything. So distribute it here, 3 squared, then a cubed squared over b to the 4th squared. Okay, 3 squared, I know what that is. That's just 9. Another property tells me if I have a power raised to a power, I can multiply them together. So 3 times 2 gives me a new power of 6. And then same thing here. 4 times 2 gives me a new power of 8. And that would be my final answer. Okay, in the next video, we're moving on to polynomials.